So we have looked on the previous video. We have looked at an example about how can we solve the finding the volume using cylindrical coordinates. But now we want to look further. What is actually cylindrical coordinate? As I mentioned before, cylindrical coordinate is the extension of polar, but we call that as polar, where we have to convert x and y into r and theta only on the 2D system, which means that if you are given a lamina, if you are given a double integral or the curve on 2D system. But when we extend into 3D system, when you have a solid, so instead of we call that as a polar, we call that as a cylindrical. Because of the idea is x and y we convert into r and theta, but the z then we can because we add another variable in 3D system, which means that to get the solid, so we assume that the z is z. Okay, so the z is just like if you have the polar, which basically it is a circle. When you do a projection along the z, so from the circle on 2D, when you do a projection along the z, where z is z, so you can see it is a cylinder. That's why we call that as a cylindrical coordinate, where you can deal with the r and theta on this plane, on xy plane. So this one you have dA, right? dA, and you convert into polar, you have rd theta, and then the z is z, so you have the height, which is we have dz. So meaning that your dv now is dz, which is the height multiplied by the dA, and we know that dA in polar is r drd theta. So now in triple integral we have r dz drd theta. So this is called as cylindrical coordinate. The way you want to find the limit of theta and the limit of r is exactly as the same as in polar coordinate system. Okay, but the z here, to determine the limit of z, then you have to look at your solid that you have. Okay, so how can we convert from Cartesian to cylindrical coordinate? So we use just like polar. X is r cos, y is r sin, and z is z. And the dv is, as I mentioned before, dv is r dr d theta dz, or you can have dz dr d theta. But normally, because of dA is part of the region, and the region should be lying on xy plane, so we put the rd theta at the back. So we first integrate respect to z. Okay, so just ignore this. So this one, if you have a physical class. Okay, so maybe I'll just look at what is the question here. Identify the example of surface, which is identify the solid where you need to apply the cylindrical coordinate. So what kind of solid that you have to apply the cylindrical coordinate? So if you have the cylinder and that cylinder is cut by a plane, then in order for you to determine the volume, for example, then it is more easier for you to solve the triple integral in cylindrical coordinate. Also, you have this one, where this one is the solid is bounded by maybe this one is a ball, and then bounded above by the plane z equal to 3. So for you to evaluate the volume of this solid, so it is possible for you to apply the cylindrical coordinate. And you have a cone, and the cone is bounded above by the plane z equal to, let's say this is maybe 3, I don't know. So just we have to make sure we have, when we call that as solid, it is a closed and bounded surface. And here if you are given a a solid where it is part of the sphere, sometimes it is possible for you to use the cylindrical coordinate, but for this one, it is normally easier to be solved using spherical coordinates. So the coordinate system that we will look after this, if you have the part of the sphere. Okay, but sometimes still possible to be done using cylindrical coordinate. So this is, I just skip this. So this is the way how can you determine all the limit of r, theta and z. Okay, so this is how can you convert. So this one is the how the cylindrical coordinate works in general, but here I don't want to explain in detail because I'm sure that you will just blur. You have no idea, right? So why not we start with the example. Okay, so I give you an example. So this is a favorite question in exam. So they will give you a complete triple integral. What I mean by complete integration is you are given the order of integration and also the limit. But then the question is, you have to evaluate this triple integral not in the Cartesian coordinate system, not in terms of x, y, z, but you have to solve them in terms of cylindrical coordinate, but meaning that you have to solve in terms of z, r, and theta. So you have to change your order where the z are the r d theta, and your limit, you have to find your limit of z. So maybe limit of z does not change, but you have to change the x and the y, because in cylindrical there is no more x and y, but z still can be z. Okay, similarly the limit of the last two integral here should be changed into r and theta. Okay, so in order for you to change the coordinate system from Cartesian to cylindrical, so you have to have the solid first. Okay, just like you have done in double integral, you want to change the order of integration. So you need the region, right? You have to sketch the region first. And also you have learned about from Cartesian to polar in double integral. So in order for you to change the integration from Cartesian to polar, you have to also have the solid. You have to sketch the solid. So similarly in triple integral, if you want to change from Cartesian to cylindrical, then you need to sketch the solid and also the region as well, so that you can determine the limit of r and theta and also z. But in this case, for z, it is okay for you to just directly obtain this one in cylindrical, but sometimes you need to sketch the solid as well. Depends on the question. But for me, I will always sketch the solid and sketch the region as well. Okay. Okay, so to answer that, first I have to, because we need to know what is the limit of r, theta and z. Okay, so firstly, look at your order of integration. So I already show you some example how can you get a solid from the limit, right? From the limit, yes. I give you an example where we have where is it? There is an activity asking you to find or sketch this one. So you can just look at my previous video. Sketch the solid based on the sketch the solid and evaluate the volume. But the question here asking for sketching the solid. Okay. Just for for your own practice on find the solid from the given limit. Okay, so now we want to work on this example. So your dv is dz, dy dx, which means that you have dz dA yx. So we know that for this particular order of integration, so your region should be lying on yx plane. Okay, so yx plane, and you have yx fluid. So now okay, we want to get the, you can determine the limit of z first, or you can look at the limit of the y and x, so that you can have the information about the region. So you can start either one. You can start with this first, or this one. So it is up to you. Okay, so let's say I want to know the shape of the region first, so I will work on this. So in this case, they give you dy dx, which means that x constant. So x constant, so based on the limit given, x is -3 to 3, and then y is negative square root 9 minus x squared, positive square root 9 minus x squared. Okay, so if you realize, these two equation is actually will give you y equal to plus minus square root of 9 minus x squared. Okay, which means that we can, if you leave your equation in this form, we have no idea the shape of the region that you should have. So we transform into a general form of equation. So in this case, you must be able to memorize all the standard equation. For example, the standard equation of ellipse, the standard equation of circle, hyperbolic, and maybe quadratic, so that from there it will help you to guide you to determine a correct curve or region. So for this, you can have, when you square both sides, you have y squared equal to 9 minus x squared, where then you have y squared plus x squared equal to 9. So we know that the y here is based on a circle centered at the origin with radius 3. So now when you sketch on the y-x plane, so you have a circle with radius 3 centered at the origin. Okay, so now for the region, we have to shade the region. So in order for guiding us what is actually the area that we need to shade, you have to refer to your limit provided. Okay, we know that now x is constant, meaning that it's based on the line, the vertical line, which because of x here is constant. Okay, so now when you read, when you refer to the given limit, so x can be positive, which is positive 3, and x also can be negative, which is negative 3. So it looks like x can be negative and x can be positive. How about the y? Maybe you have to take note, maybe y only positive, or maybe y only negative, or y can be both. If you look at here, so based on your line that you sketch, the vertical line, so if you look at here, okay, now you read y, the lower bound of y is negative square root. So negative square root is referring to the semicircle, where the semicircle is for y negative. So y negative, the curve of y negative is down here. So meaning that for the first line, that is lower bound, and similarly you can refer to this line also, that is the lower bound. And then when you keep increase the y, so it end up to be the positive square root. The positive square root also part of the circle, where y is always positive. So we can see that the region that we need to shade is all over the circle. So we have, for the region, we have a complete circle. Okay, so from here, since they ask you to solve using the polar, so now your polar is r d theta, isn't it? Okay, so you can determine straight away the limit of r and the limit of theta using the region that you have sketched. So r, R, you know that the highest R is 3, the smallest R is 0, because we know that R0 is origin, and you can see that the origin is also part of the circle in the region. So the R is 0 to 3. And theta is the angle starting at the x-axis positive. Since you have a complete circle, so your theta is 0 to 2 pi. So now we already obtained the dr and the d theta. Now we want to look at the dz. Okay, so now you have to read the limit of z in here. So the limit of z given is 0 to 9 minus x squared minus y squared. So what is 9 minus x squared minus y squared? If you sketch the surface. Sometimes you don't need to sketch the surface. If you can imagine directly that your upper bound and your lower bound, so it is okay, because sometimes the mark for sketching the solid is just 1. So I can see that the highest mark always 1. So why do we need to spend extra time on sketching if you can imagine easily in your mind, so that you can determine the lower and the upper bound in terms of r and theta. I hope that you understand what I mean. Sometimes you need to sketch because we have no idea the solid looks like, and because you are not sure what is your lower bound and what is your upper bound, then you have to sketch. But in this case, it looks like you can imagine you are inside the solid, and your lower bound is a floor, which is z equal to 0, and your upper bound, okay, if you want to sketch also possible. What is that? So this is actually a bowl concave down, right? A bowl concave down, and this is 9. Okay, so this is your solid actually. So when you have z equal to 0, so this is your floor, bounded below by the floor and bounded above by the bowl concave down, and the highest value of z is 9. So meaning that when you are standing inside the solid, so you can imagine straight away your lower bound is z equal to 0, and who is covering you? What is the surface that is covering you? So the surface is covering you is z equal to 9 minus x squared minus y squared. Okay, but then we don't want the z in terms of xy, because now we want to solve in cylindrical. So you have to convert x and y into r or theta, into a polar function. So as we know that 9, now when we factorize the negative, you have x squared plus y squared. So we can rewrite 9 minus r squared. So now we already transform the upper bound here in terms of cylindrical or polar. Okay, but you don't need to change the lower bound because that is a constant. So 0, 1, 2, 3 is a constant. You don't need to convert into cylindrical or polar. So now we already obtain your upper bound in cylindrical coordinate is 9 minus r squared, and your lower bound is 0. For this, if you want to sketch the solid, complete solid is okay. But if you don't want to sketch because it is easy for us to imagine in your mind, also possible. I understand it. But sometimes the solid is quite complicated to imagine. So that is something the sketching of solid is very important. Then you have to sketch it. But for this, you can imagine directly because the limit already given, right? But you can just imagine I'm standing inside the solid, and my lower bound is the floor, and my upper bound is the surface, which is a bowl concave down. So we can imagine that easily, isn't it? Okay, so now we start to convert our integral here, but now we want to convert into cylindrical. So your function x squared, you have to convert into polar. So you have r cos theta square, and your dv is r dz, dr d theta. So we put the RD theta at the back because our region is a circle on XY plane. So that's why we put the RD theta at the back. So now based on our limit of theta that we obtain, 0 to 2 pi, R is 0 to 3, and just now dz is 0 to 9 minus R squared. So now everything's now in terms of only R, theta, and Z. So now this is already in cylindrical coordinate. Okay. But then we have to, maybe I have to expand and simplify the form. So R squared, R, so R cubed, cos square theta, dz, drd theta. Okay, firstly, we have to integrate respect to z. So there is no z here. So these are all constant. So R cubed cos square theta, z, so z, 0 to 9 minus R square, drd theta. So now we only have R and theta. So R cubed 9 minus R square cos square theta, dr d theta. So I expand that 9 R cubed minus R5 cos theta, cos square theta, dr d theta. So cos theta, next we have to integrate respect to R. So cos squared theta is constant, so we just integrate this. So 9 over 4 R4, 1 over 6 R6, 0 to 3 d theta. Then we have to evaluate over 4, 3 to the power of 4 minus 1 over 6, 3 to the power of 6. And then integrate cos square theta, d theta. So you can evaluate this using calculator. And to integrate this, please don't give me cos cube 3 over 3. So that is wrong. Okay, because this is two layers of expression. The outer is a square function and the inner function is cos theta. Then you have to, normally for this, you have to reduce the power to be 1 using identity of trigo. Okay, so please think about it. Okay, find it yourself. I just give you the final answer. We evaluate this, we'll get 243 over 4. And please change this into a power of 1 using appropriate identity of trigo, which is this one. You can look at the list of formula that I share with you. And in fact, you can see that in the test that we give you, we give an attachment about the list of formula that you can refer to that document. So then after that, you will get this one. Okay, so please do it yourself. Okay, so that is how can you transform from the Cartesian coordinate system into cylindrical coordinate.